Hi everyone, my name is Prashant Mohan Thakur and welcome to Competition Valley. Today we'll be doing the first class and this is pertaining to number system. So this would be ideally the first class for number system as well. So in this section we'll see some sort of what different types of number are. We'll just try to see the definition and then how we can apply these numbers and all. So let's start. So let's for a moment assume that this is a number line. So we can take it as minus infinity plus infinity over here, and this is nowhere. So all the numbers, all the real numbers. So when we talk about number system or when we talk about numbers, so basically it can be categorized into real numbers and imaginary numbers. So real numbers, all other numbers which are not imaginary are real numbers. I'll talk about what imaginary numbers. Imaginary number, for example, minus root 1, or we can talk about I square. So these are imaginary numbers. These are used for, these have a different purpose on its own. But generally in arithmetic or in basic algebra, we don't use it. It is of course used in binomial expression, and then we use it in astrophysics and everything else, wherein we use iota sort of thing over there. But over here we don't need it. In such courses like competitive examination, it's rarely asked. Okay, if needed, we'll talk about this as well. But for the time being, let's focus on real numbers. So what real numbers are, we'll try to learn from this number line. So as I said before, all the numbers can be represented over here, irrespective of the fact is it rational, irrational, prime, odd, even. Okay, so how do we define and how do we differentiate between these numbers? Okay, so that's what we'll try to learn over here. So let's say on the right hand side of 0, we have all positives, and on the left hand side, we have all negative. So let's say this is 1, 2, 3, 4, and till infinity. So once you start walking from this number, like number 1, and then you go all the way to the right, it means all the numbers that you see right from number 1 to positive infinity, these are natural numbers. So all the numbers up to the right from 1 towards positive infinity is natural number. Now, if you consider 0 as well in this series, then it is a group of whole numbers. So what do we learn? That 0 is not a natural number, it's a whole number. This is something we learn over here. As 0 is nothing but 0 is a whole number. It's not a natural number. That's one thing. The second, hang on, come on, over here. Fine. So this is what we call as a whole number. Now, for example, let me just delete this. Let me just rub this off and let me draw a new line over here again. So, okay, again, so 0. So we have learned what are natural numbers and how does it differentiate between whole numbers. Okay. Now on the same line, if we take the minus component as well, okay, then like minus 1, minus 2, minus 3, minus 4, everything else, then it means that we have considered integers. That's what we call integers, a group of all the numbers, whether positive or negative integers. And then if we consider, like, let's say you have 1, 2, so you have 1 by 2, you have, and then 1 by 3, 1 by 4, anything, not necessarily in order, then it means that we have considered rational and irrational number as well, because those are in the fraction. Odd numbers, we know about odd numbers, all those numbers which are not divided by 2, or which upon division, if you divide 2 by any odd number, it would leave a remainder of plus 1, or it would leave a remainder of minus 1. For example, let's say 5 is an odd number. So when we divide 5, it gives a remainder of 1. So what we learned, that odd numbers are of form 2k plus minus 1. This has some good application. We'll talk about that once we are doing this topic. But for the timing, just remember any number that does not get divided by 2 is an odd number. For even number, it's in the form of 2k, because all the even numbers will be dividing itself by 2. And Then we have prime number, any number which just have two factors, just two factors, the number 1 and the number 8, just two factors. Then we have composite number. Composite number are a set of any numbers which have at least three factors. For an example, 6, 9, 8. So any number which would have like 4, any number which would have at least three factors. It could be more than that as well, but at least it should have those. Okay. So now the point of focus in this video would be rational in and irrational number, because that sets the basic for this chapter. So we'll start with now we'll talk in depth about rational and irrational. We have all studied about this previously as well, of course, in class 7, 8, or 9, whenever, according to different syllabus. So rational number, any number that we can break down in P by Q form, where Q is not equal to 0 and P and Q are coprime to each other. So coprime to each other. So now we have seen there's a new term called coprime. So what is coprime? So as the name suggests, prime and co means existing together, co-ed. So let's say we have a set of number, we have been given a set of number, let's say 4 and 9. So what is that number which is common in both these? So in 4, if we see the factor of 4, we have 1, 2, and 4. And 9, if we see 1, 3, and 9. So we see the only number 1 is common amongst the given numbers. So it's a coprime. For an example, 6 and 8. So we see that 1, 2, 3, and 8, we have 1, 2, 4, 8. So I see more than one numbers are common. So it's not a coprime. Just for example, 6 and 9. Again, 6 has 1, 2, 3, and 6 factor. 9 has its factor as 1, 3, 9. So we see again, we have more than one factor. So it's not a prime. Okay. Now 6 and 11. You see 6 again, 1, 2, 3, 6, and 11 again, 1 and 11. So these are coprime. So coprime means it should be in the simplest of the form. It cannot be further broken into any more fraction or anything else. That's exactly coprime means, and that there should not be any common factor but the number 1 itself. So when we talk about rational number, P by Q should be Q should be coprime to each other, and Q should not be equal to 0. That's the basic. Irrational number, it cannot be converted into P by Q form, where Q is not equal to 0. It can't be done in P by Q form. Okay, we'll talk about some examples. Let's say rational number, we have 1 by 3, 2 by 7. You can think of any number which can be taken into account as P by Q. Okay, 4 by 16. Again, 4 by 16, these are not coprime. So this is not a rational number. But yes, once it gets to 1 by 4, then it is the rational. Now, how about rational number? Why cannot rational number be? Why we cannot consider rational number as P by Q form? Because if you see P by Q form, so let's say we have root 2. Okay, so let's try to see root 2 is an irrational number. Of course, there are ways to prove it, but that's something out of the syllabus for the time being. That's not required. But why we cannot consider root 2 as a rational number? Okay, so we'll try to see that. So once we break root 2, so let's see what do we get. I'll try to go for as far as I remember. So let's see, 2, 1, 3. Then we have 5, 6, 2, 3, 7, 0, 9. And it keeps going. It keeps going. It keeps going. Similarly, pi, 22 by 7. So we know very well that it is 3.14. But this is an assumed figure. It's not the exact figure. Okay, if you want to add, because there are still reads going on. So if you want to go 1, 5, 9, 2, 6, 5, 3, 5, and keeps going on. So there's a pattern, and that pattern we'll be using in rational number as well. So let's check what's the pattern over here. The pattern is that none of the numbers, there's no such pattern wherein any of the numbers are repeating itself in a defined manner. The same goes with over here. You can check the same with root 3, root 7, anything. So it has no pattern of repeating itself. That's the first thing. Second, the remainder would never be 0. So in irrational number, we have two properties, that r will never be equal to 0 and the quotient will never repeat in a defined or in a defined pattern. Okay, so that's why we call them as irrational, because we cannot break them all in p by q form. And why we cannot break them in p by q form? Because there is no such definite format that we can conclusively we can derive from it. So how about rational number? Let's see. So in rational number, let's say we have 1 by 3 for an example. So we start the long division process, because yet we do not know the other methods. I'll teach you once we are in the division method process chapter. So let's start over here. So 1 again, 3 3 9. So you can keep continuing this process, and this process will keep repeating itself. So over here as well, r is not equal to 0. But if we talk about the quotient, you can see there's a definite pattern over here. The pattern is that 3 is repeating itself. So we can say that, we can conclude over here that 1 by 3, 1 upon division, this is what we get. So that's why we call this as a rational number. Now we can consider quite a couple of more examples as well. So we'll do some more. Now remember, this has repeated, okay, because this would have some application again. So that's why I gave you this. So we have done, right over here, we have done 1 by 3. Now let's say we do 1 by 7. Again, let's start. So 3 0 28 2 4 and then 2, I'm sorry, then 2 6 0 7 4 0 35 5. So as if now it might look that this, you see, as if now it might look that this is no pattern and it's not coming, the remainder is also not coming 0, and this quotient has no pattern. But hang on, let's give a couple of more tries. So again we would have 5 and we have 7 7 49, we have 1 0, then we have 0, okay, 9 0, then we have 7, okay, I believe, yeah, it should be 1 over here, I lost somewhere. 7 7 3 0. It's a mistake over here or what? 3, okay, this should not be, this 0 should not be there. 7 4 28 2 0 7 2. So let's continue here. 7 2 14 6 0 7 8 56 4 0 7 5 35. So what do we observe now? Now let's relook the numbers. So we have 1, okay, 1 4 2 8 5 7, and the same thing is repeating, 1 4 2 8 5 7. So even though remainder is not equal to 0, we see that numbers are repeating, or we can say recurring, in a defined pattern. So we can conclude over here that 1 by 7 upon division, we can get 1 4 2 8 5 7, and we can put a bar. Now by putting bar, it means on all the numbers wherein the bar is given, it means these numbers are repeating itself. So you have 1 by 7 over here as well, which is repeating. So this was another example. So we have done 1 by 3, we have done 1 by 7. Now let's do another one. So we can take over here, let's say this one. So we can take, let's say some 3 by 5. So upon division, so 0 and we 6 30. So it has left nothing, 0. So r equal to 0. So now we have seen there are three three models over here. These three models have different things, different features, all at all. So it was 3 by 5. Even 1 by 5 would be fine, even if you divide 1 by 5. Yeah, you have 5 by 1, 0, and 10. So 1 by 5 is the same thing. So when we did 1 by 3, we see that, now I'll use mathematical terms, so pay attention. 1 by 3 was non-terminating. Non-terminating means where you do not get remainder as 0, okay? Where we do not get remainder as 0. So it was non-terminating but recurring, because 3 was repeating itself again and again, if you remember. Over 7, the same thing again. It's non-terminating but recurring. But with 1 by 5, it is a terminating. So what we have learned that there are two different types of, if we want to categorize further rational number, if we want to break down. So there are two different types of rational number. One of them is what we call as terminating. In terminating, basically your remainder will be 0 after a point of time. And then you have non-terminating but recurring or repeating, whatever you may say, that it will repeat after a point of time, terminating. So these are with rational number. With irrational number, what do we have? Of course, we would never have r equal to 0, so it's going to be non-terminating and non-recurring as well. Okay, so briefly you can say that all the numbers which are non-terminating and non-recurring, these would be rational, sorry, irrational number. These would be all irrational number, and all those which are terminating and not, even if it's not terminating but it's recurring, these would be all rational number. So that's how you can categorize it. Now let's go back to the case 1 by 3. Okay, so for an example, let's say it is given. Okay, we know how to do this from here. We have learned how to. It's a simple long process, long division process by which we can derive the value of x. Now let's say if you have been given the value of x, let's say we have been given the value of x is 0.425 bar on all of these three, and we are asked to convert into p by q form. So there's so many ways. So the number one method that we have been taught in schools as well, that okay, there are three numbers after the decimal, and we need to make sure, first of all we need to understand that 0.425 means 425 425 425, of course, after the decimal. So it means this set of three numbers, which is 4 to 5, is repeating after again and again. So in order for us to get to a point where we can solve it, we have to ensure that this number should be out of the decimal portion. It should be in the non-decimal form. So what we have to do, so we see there are three numbers that's doing answers. So we multiply. If you multiply by 10, let's say if you multiply by 10, so it will be only 4. And then we have 0.25, 425, 425, 425. So it will be difficult for us to divide this 1 and 2. So we cannot use 10x. So let's say if we want to multiply 100x. So we know it very well that if you multiply by 100, let's say it's 0.42. So x, so if you multiply 10x, it will be 4.2. If you multiply 100x to it, it will be 42. So similarly, so for 100x means that there will be two numbers that will be out of the decimal. So if we do 100x over here, if you multiply 100 on both the sides in 1, so it will be 42, and then we'll be left with 0.5, 425, 425. So again, it will not be, we will not be able to do any simplification over here. So what we'll have to do for us, so for taking one number out of this decimal, we do 10x. For if we want to do two number, we do 100x. So for doing 3, we need to multiply it by 1000. So therefore what we'll do, we'll multiply 1000 on both the sides of this number. So we would have 1000x is equal to 425.425 we can, and we already had x that was 0.425 425, 425, 425. So now you can see that it is easily subtractable. We have 990x is equal to 425, or x is equal to 425 by 999. So that's one of the way we can do. Now we'll try to do it in the second method as well. We'll try to apply that. So let's do that. So okay. So again, let's do the second method. Method 2. So x equal to 0.425 bar. What we can do is we have to convert it into the p by q form. So q first we'll derive. So listen to me very carefully. For all the numbers that is repeating itself again and again, we put 19. So for 4 it's 19, for 2 and for 5. So for all the numbers that is repeating individually, if it's repeating 3 times, we are going to put 3n. If it is going to repeat once, we put just 19. So for all the number which is repeating itself, wherein we have the bar, we are going to put 19 for each one of them. And in case it doesn't, then we are going to put 0. Okay, I'll come on to that part as well. And then we have 4 to 5. How do we get numerator? From all the number from that's repeating, take that part that is non-repeating. So for 425, is there anything else that is not non-repeating? Nothing. So it's simple, 4255999. Let me explain to you. How do we get this 999? For all the numbers over here, we see that 425. There are three numbers that are repeating, three digits that are repeating itself over here. So for every digit, we put 19. And that's how we derive 99. And how we get 425? For all the numbers from the entire number, take that part which is not repeating. So there's nothing. So we get that. That's very simple. So now we'll do some more questions so that this concept is very much okay. So I'll just doing the second method, method 2 now. Very simple. We need to do the p by q form. So I know only 5 is repeating, so 19, and these two are repeating, non-repeating. 4 is non-repeating, and this is also not repeating. 2 is not repeating. For everything that is non-repeating, we're putting 0. And how do we get numerator? 425 minus 42. So we get 523, and then 8 and 3 by 900, and so we get 383 by 900. And this is what we got by second process as well. So I'll show you method 1 once again. I'll do it. X equal to 0.425, 100x is equal to 42.5, 42.5555, whatever, and 1000x is equal to 425.555. We take it over here. We have 900x equal to the same thing, I believe, 5 to 3, 383, or x equal to 383 by 900. Now we are going to do speed up the process completely. So now we are going to do it without using our pen. Okay, ready? Let's go. So we have x is equal to 4728. So how do we convert into p by q form? So very simple. 99004728 minus, I'm sorry, 4728 minus 4786 by 9900. Simple. Again, we have x equal to 0.027. So in p by q form, and so we know what is our denominator. See, everything is repeating over here, all the three terms. So 999, and over here there's nothing that's not repeating. So 27, 39, 333, and then we have, I believe, no, okay, 91, 93, 27, 1 by 37. So this is how we do it. Okay, if you want, we can do a couple of more questions, but I would want you all to do it without touching your pen. Okay, so again, let's do it. So x equal to 2 point, or let's say, even if it doesn't matter, but 2, okay, x equal to 2.472, just for an example. Okay, how do we do it? Okay, so again, so we already know about 2, that it's going to be with same thing we have to do that we have done before as well. So I believe my sound was gone for a moment, so I'll rectify that. So x equal to 2.42. I'll just tell you how this step has been done. Let me just select this and let me start doing this again. Okay, that's it. So x equal to 2.472. So the same process what we know about p by q equal to 472. So we can see these two are repeating itself and this is non-repeating. So what we're going to 99 for terms that are repeating, for non-repeating, and we see that it is not repeating over here. So we take 8, 6 to 4, and 24 by 990. Again, we divide it by 2, and we whatever the results are. Okay, if you want, you can cross check it over here as well. X is equal to 2.472. So first thing we do is we do 10x, so that we have 24.727272, and then we do it, we multiply by 100, so we have 2472.7272. This is crossed out. We have 990x is equal to 8624 to 48. X is equal to 2448 by 990. So I hope you would have understood this new concept and you would have learned something new. In next class, we'll taking forward these steps and we'll be learning some new concept and tricks about solving these questions. So this is all from me for this class. Thank you for watching Competition Valley. Thank you for your time and patience. My name is Prashant, and see you in the next video.